Okay, so in this session, we're going to be talking about what I'm calling broadly cross-app security. And this is the first session of several because there really is so much to cover. I keep realizing the more I try and build this content, the more still there is to cover. How many sessions are going to be? No idea, probably a lot, actually. But I do think it makes sense to do a modern take on this content. In searching the web for this across various resources, in my mind, there's not a lot of very robust content that's oriented towards application security testers on these topics. And so I think it makes a lot of sense to cover these in depth. And so that's what we'll be doing. And we're going to start out just looking roughly at same origin policy, introducing a number of key concepts. And there will be a number of topics that are touched on in this session that we won't get to fully cover, that we'll have to cover in future sessions. So just be aware that not everything is that comes up is going to be necessarily covered comprehensively. I do have an ending slide where I'm discussing the topics that will be covered another time. So I'm using the terminology cross-app security because it's kind of a broad way to capture all of the different mechanisms in play that impact the security of applications in relation to one another. So when we're talking about cross-app security, we're talking about protecting one app from another app. And usually what we're talking about there with respect to web applications are applications that run within the browser. So one of the most common attack vectors is you have a victim user who has a relationship with some application that they trust, and as an attacker, you cause them to land on your page. And the question is, what can you do on behalf of that user against that trusted application? That's one of the most common scenarios in cross-app security. There are other situations as well that arise. We're not going to be talking about all of the different attack cases today. We're going to be mostly focusing on the core security mechanisms and some of the concepts behind those. But eventually we will explore all of the different attacks, the context that you would need as an attacker, what the full chains look like. And I think we'll probably end the series by looking at a number of recent attack vectors, bugs that have been awarded bounties that rely on abuse of cross-app security mechanisms like same origin policy. So that's ultimately the direction that we're going. So key concepts, starting with some of the absolute basics here that probably most folks are familiar with. So I won't spend too much time on this page. I think everyone is probably familiar with URL. Really, the only thing I wanted to point out was ETLD +1, which is your registrable domain, essentially. That doesn't always line up. In some cases, there are ETLD +1s that are not registrable. I'm not going to talk about those. But in this case, for our purposes, it makes sense to think of a domain that you can register if you want to host your application from it. That is going to be your ETLD +1. And then owning that domain, you can add subdomains on it in order to make distinct origins. Of course, origin is a concept we're going to introduce in a moment here. But first, we're going to look at the full URL. This won't come up so much in this session, but it will come up more so in future sessions. The only reason that I thought I would include this is just because there are some elements of it that are easy to forget for, if you're not using them day to day. So in particular, a couple of features that you don't commonly see, or you might not be manipulating very commonly, the user component, as well as at the very end, the fragment component. Especially if you're working a lot in Burp, it's easy to get really focused on what is the data that you're sending to the remote application that you're testing, and you'll never see the fragment component of URLs because this actually isn't sent to servers. This is just retained in the browser. Now, that doesn't mean that it's not important from a security perspective. In many cases, it is and it can be. Just one example would be cross-site scripting, where you have JavaScript logic on a page, and it's consuming the value of this component of the URL. There are other ways in which the fragments can come into play and have implications for security. So it's always worth, when we're thinking about the core elements of the web that we're interacting with, and the core concepts and technologies, like even just URLs. It's very easy to think of it as far as a very simple mechanism that does not deviate much, but the specification allows for quite a bit of flexibility, and sometimes keeping in mind those other features and elements that you don't commonly use day to day, like just including a user component within the URL, sometimes might have implications for the security of a system that might make assumptions about what a URL is that differs from what the specification defines. So it's important to keep that in mind. So now we're going to introduce two very important concepts, origin and site. So the origin is quite simply the combination of the scheme, the host, and a port from a URL. So anything that has a different host name, so a different subdomain, for example, anything that has a different scheme, HTTPS versus HTTP, even when you have the same host and scheme, but you have services running on different ports, those are all distinct origins. So when we introduce same origin policy and we talk about security in relation to origins, it's very important to understand what makes an origin. Of course, it's quite simple, but it's also important to understand the concept of a site, because this does come up from time to time. And in general, I think the best way to think about that is the scheme plus the registerable domain. So if you have two different or if you have one registerable domain and you assign multiple different subdomains to it, all of those subdomains still fall under the same scope of a site, right? So they share that site scope, but each of those would be a different origin. So when you think about a site compared to origin, origin is actually more strict than site is. Site is a lot more permissive over what can share the scope of a site. Origin, of course, more restrictive. Very important to keep in mind. There are a lot of mechanisms that are governed by the origin, the concept of the origin, but there are also a number of mechanisms that are governed by the concept of a site. And the same site cookie attribute, which we will cover eventually when we do a deep dive into HTTP cookies, is one of those mechanisms. Now, what I didn't put down there is cookies themselves, because cookies kind of follow their own mechanisms as far as scope. They roughly fall within under site scope, but there are some exceptions to that. So HTTP cookies don't even neatly fit in this table. And there are some other mechanisms like that as well, where the way in which it works isn't necessarily governed by origin or site, but nevertheless, these are kind of the core two concepts that are important to understand and keep in mind as we go. So, as you know, this session is largely about same origin policy. You'll see many different definitions for it. I came up with my own because I think this best captures it naturally. Otherwise, I would have used another definition. It's not something I think that can be very strictly and narrowly defined. It's more of an overarching concept and a model than it is a specific set of rules, because those rules, how it's implemented, change over time. And there are also exceptions to it. So I've defined it as the core web security model that attempts to restrict different web apps from unintended violation of the confidentiality or integrity of other web apps. So we're talking about, and of course that's based around the origin. Maybe I should have specified that in the definition, right? So how do we define different web apps in this context? I'm saying web apps that are separated by the boundary of origin. So they have two distinct origins. And it's important to keep in mind that there are a couple of different contexts in which we can have different origin applications. We can have different origins that do not fall under the same site scope, but we can also have distinct origins, like two different web applications that are different origins that share a site scope, right? They share essentially that parent domain. And there are implications for security when thinking about that, but we're going to focus right now on the protections that are offered when two applications have distinct origins. And this should also be the ideal that developers strive for when developing and deploying applications, that each individual application should make use of these built-in protections of the same origin policy by hosting their content from distinct origins, right? Anytime that you have two different applications that share an origin, they're going to be missing the security boundary that we can apply with same origin policy. So ultimately, same origin policy is the security model that protects distinct web applications. Of course, again, caveat when they're served from distinct origins. It is a logical boundary between apps from different origins, and it doesn't prevent all interactions between origins. I say it's messy because I would say it doesn't even protect against all interactions that you might expect that it protects against. It's something that has evolved over time. What the default protections are, what the possible circumventions of those protections are, the ways to relax them, the different quirks that exist that may be considered violations, but nevertheless are required for the web to function as it is. Ultimately, the state of the web as it is now is a result of a system being built and developed organically over time, and having a lot of infrastructure built around how that system worked in the past. A number of assumptions are made with respect to how the web works. And then from a security perspective, everyone interested in security came along after and said, well, let's try to secure this without breaking how the web initially developed. So that's kind of what has led us to the current state. Security has been largely an afterthought to how the web operates. And surely if we could redesign the web from the ground up, we could build it more secure and I think also a little bit more sane and practical and easy to work with. As it stands, it can be quite confusing. It can be quite complicated. There's a lot to keep track of, and we're certainly not going to touch on everything in this session. Notably, same origin policy is enforced by the browser. So it's something that largely governs how applications behave once you've loaded them within your browser. Very important to keep in mind. So I think the best way to begin by examining the protections of same origin policy is just by looking at, by default, presently on the web, what does it allow and what does it deny? And so to do that, we're just going to look at a number of examples. And so these examples cover the many different ways in which different applications can potentially interact on the web. So what is permitted generally by default is cross-origin writes. Of course, there are only a few ways in which we can potentially do this. And the classic example is a cross-origin form post. So this is an HTML example where our action is targeting some origin, which we're assuming is going to be different from the site that we're on that actually has loaded this form. And so we would call this a cross-origin form post. The method is specifying a post. We also have input, which is going to be our parameter, and there's a button on the screen. So the user is required to click the button in this case in order to send that cross-origin post. And so this could very well be a write. It could be a state-changing operation where we send this post request to the remote application and it does something on behalf of the user, the client that is sending that request. And that obviously has implications as far as cross-site request forgery, which we're not going to touch on this session, but cross-site request forgery, just at a high level, is a type of attack where you are sending a request, in this case, across origin, and you are trying to instigate a state-changing operation on behalf of a user. And so a cross-origin form post is one way to do that. Now, I said that cross-origin writes were permitted, but we can't just create any type of request that has any structure and send that from some site that we're on to some other origin. There are a number of restrictions that do apply by default. So there are only a small number of permitted HTTP requests that we can send by default. We can send GET, we can send POST, we can send HEAD requests under some situations. One thing I do note here is that we can send options in some cases, even without using mechanisms that normally should allow us to send options requests. So we're not going to do a deep dive into CORS. I'll talk about CORS a little bit, but CORS as part of certain requests, we'll send a pre-flight request, which is an options request. And this is important to keep in mind because if you have a system and you're looking at it from an attacker's point of view, and you don't have a permissive CORS policy that will let you send any type of request that you want, you can nevertheless still send options requests as pre-flights. And it may very well be that an application and the way it works can be abused by pre-flight options requests. That's probably quite rare on the modern web, but nevertheless, it's something to occur. As an attacker, it's important to keep in mind all of the tools that you have available. So keeping in mind even the way that you can send requests by side effects, not by necessarily the intent of the mechanism you're trying to use, those are worth knowing about and using where appropriate. Additionally, there are only a small number of HTTP request headers that are permitted, and the ways in which we can manipulate these are limited. And we don't need to focus on those right now, but one thing that you'll see is missing from content type is sending like JSON data, for example. So sending a cross origin post request with JSON data in it, it's going to require a little bit more than what we're permitted to send by default. And you'll see that there are bug bounties that have been awarded for different hacks that try to abuse sending data to correspond to or to be interpreted as JSON, even when the server does not allow it with a CORS policy. We're not going to look at those quite yet, but perhaps in another session. And there are some exceptions to the above as well. So there are some complex exceptions, but we're not going to touch on those here. So just to summarize, if we look at a number of different ways in which we can initiate requests cross-origin, and this isn't perfectly complete. There are many other mechanisms where we can initiate cross-origin requests. iframe is one that comes to mind, where we can embed content within a frame. I didn't put that in this table. There are others. This is just a summary of some common mechanisms, the methods that are allowed, and whether CORS is required in order to relax the protections of same origin policy in order to allow us to send other types of requests. And so you can see down at the bottom, sending certain HTTP methods is typically going to require a CORS policy that permits us to do so. One thing that same origin policy does block us from doing is cross-origin reads. And this might seem a little bit counterintuitive immediately because the web is largely composable of different components and resources. Any given website might be composed of many different scripts and style sheets and images and frames, and all of those coming from different origins, different CDNs, different applications out on the web. And so you can build an application that on the client side is built of many different resources that come from all over the internet. But crucially, what you can't do with those resources, if you're running JavaScript in your app that's loading them, is you can't actually read those. So in this example here, we are using a script to open another window, cross-origin, and then what we're just trying to do is log that content to the console in the browser. And in particular, we're targeting the content from the body of that response. And this will be blocked. And if you try to do this in your console, and by the way, the console is a great location where you can run JavaScript code that runs within the same context as the code in that page, in that DOM. So it's a great place to trial what you can and cannot do as far as cross-origin interactions. So in this case, I just ran the same code directly within the browser DevTools in the console, and it gave me this error, permission denied to access property document on cross-origin object. And so that is essentially an implementation of same origin policy that is enforcing that protection. We shouldn't be able to read things that we retrieve elsewhere on the web because the context in which we're retrieving that might be such that it's our application should not have access to it. And one common example, and we're not going to go deep into HTTP cookies in this session, but any request that is sent from your browser to a trusted site where you have cookies that are going to be sent automatically, you could be making an authorized request and retrieving sensitive data. And so same origin policy is trying to protect you from malicious sites that are trying to send those types of requests that are authorized on your behalf, because the browser has cookies. It's sending those cookies that you've already ensured are in an authorized context by logging into some other application. It's the same origin policy blocks the read of that data. Now, that data is still being returned. Keep in mind, right? That data does come back to the browser. It's the browser that enforces same origin policy and prevents whatever code is running in the context of that origin in that page from actually reading your data. So as I mentioned, cross-origin embedding is in fact permitted, so we can embed, and I think there are probably things that are excluded here, but we can embed images, scripts. We can frame other pages, which has very interesting consequences from a security point of view. There are different types of media that we can embed. We can embed style, and all of these we shouldn't be able to read. We shouldn't be able to read directly these resources when we embed them, because these ought to be blocked by same origin policy. And what we'll see, however, is that nevertheless, there might be ways in which we can abuse the way in which these resources are loaded onto our page in order to infer information about them, which could be useful from an offensive security point of view. Now, a common, well, I shouldn't say common, I should say an old school attack, if I remember correctly, that used to exist would be loading an image from another origin, and you might not think that would be sensitive, but if there is an application that is hosting images that you have uploaded that are private to you, and by sending a cross-origin request for that image, it's sending your cookies, and you pull, as an authenticated user, those sensitive images to embed on an attacker's site. You don't necessarily want the attacker to be able to see the content of those images. But there have been many ways over time to actually read those images. I think one of the old techniques was to use to put it on a canvas and read the pixel values of those images. I don't think you can do that now, and I can't immediately think of a way to read images cross-origin. But there used to be all kinds of deficiencies in same origin policy and how this was implemented that would allow attackers to overcome these protections. And one of the complicated spaces that we get into that we will be talking about is the interplay between same origin policy, what it permits and doesn't permit, as well as the assumptions that applications make in terms of how they behave and what functionality they implement and how they protect that functionality. And where you'll find a lot of vulnerabilities relating to what appear to be violations of same origin policy, or at least around the edges of it, are because of that combination of things where same origin policy does not restrict something for whatever reason, and the application doesn't really adhere to that, or isn't really mindful of that restriction. And so there's a combination of factors that, as an attacker, allows you to exploit something that appears to ultimately be a violation of this protection between origins. So another behavior that is blocked now, and so there is our canvas element. So this particular attack is an attempt to load an image cross-origin and then try to read it, get that image data pixel by pixel, and it doesn't work. It is blocked by the browser. What is permitted is cross-origin script execution, however. And this is a very interesting one, and obviously is worth being very aware of from a security perspective. You can embed JavaScript cross-origin. Now, you can't still read that JavaScript, even though that JavaScript is going to run and execute under the context of your origin. So this has major security implications, and is one thing that in many cases is relatively, I would say, insecure by default. So if you are, it opens up applications to significant supply chain attacks as one example, which is something that same origin policy is not designed to protect you from. So when you're embedding the script on your page, you're saying that you explicitly trust it, and it can run with the same level of permission as every other script that is loaded on your page. So there's no model built into the browser really to isolate or limit the capabilities of scripts that you pull into your page like this one. And there have been proposed approaches and models for making this more secure and providing more limited access. There are a number of workarounds that exist, but same origin policy does not, once you've loaded a script in, it does not protect you from that script if it's your site that you're trying to build securely that's loading that script. Now, what it does protect is it does protect the resource owner of this script. So if we're loading the script in, we actually can't read the contents of that script. And that's protecting the resource owner from situations where there might be sensitive information in that script. In general, it's considered a bad practice to have sensitive data within JavaScript content because there have been traditionally different ways where attackers can abuse embedding and the behavior of that script. Because remember, this JavaScript is still going to run within the context of our origin and DOM. So the actions that it takes, because it interacts with things that we can interact with, like there is a shared interaction space. So depending on how it behaves, we still might be able to infer things about the content of that script. And so even though same origin policy is trying to provide a protection here where it's not letting you just read all the contents of the script, nevertheless, there are ways in which we might be able to infer what's in it just because of what we have to do to be able to run this script within our page. So it is a really good practice to, as a developer, be mindful of not incorporating sensitive information into JavaScript files and avoiding situations where the execution of those JavaScript files in some context might be undermining the security of your application. What is blocked? Reading scripts. Of course, we just mentioned this. And this is just a simple example where we take a script and you can see that I'm referencing the document and the first script that's loaded, which in this example, would be this one, and trying to get the text from it. And it doesn't work. It's blocked. We can't log that to the console because we're not allowed to actually read that script content. So those are broadly the protections of same origin policy. It's largely about preventing us acting in a certain origin within the browser from reading other data that comes from applications cross origin. But there are a number of workarounds. There are a number of things that same origin policy permits for the web to function. And there are also a number of abuses, which in my mind are largely mechanisms that exist that are kind of vestigial of an old school web that need to be maintained so that old web applications and sites still function, but can often be abused for different types of attacks and probably wouldn't exist if we were to redesign the web now. So the first one that comes to mind is cross-origin resource sharing. And this is interesting because it is not a security mechanism. I think people think of it as a security mechanism, but it's kind of an anti-security mechanism. It is a mechanism that is designed specifically to relax the security that is provided by same origin policy. So CORS has only the effect of lowering the security of an application. And so it's very important to be mindful about the way in which it's implemented. And it's very common for different security issues to arise from it being overly permissive. JSON-P is another one that is worth mentioning, and by the way, all of these I'll have further slides on in this session. We're going to look at these a little bit in greater depth, but just a high-level overview for now of what all these mechanisms are. So JSON-P, I call it an old hacky technique for cross-origin HTTP reads. It was something that was used prior to CORS more commonly. it probably shouldn't exist anywhere today, but we still see it. Post message is a mechanism where you can communicate across origin, and this is designed to be able to communicate across different applications and different pages. It's designed for that purpose. It doesn't mean that it's always going to be secure. There are security issues that do arise from insecure post messaging. Metadata reads, this is kind of what I would consider an exception to same origin policy. So there is some information that can be obtained about resources that you load and embed on your site, even if you can't read directly those resources. In many cases, this can be abused, leading to attacks like cross-site leaks. But it also highly depends on how the application behaves and what assumptions it makes. Moving on, even more exceptions to same origin policy. So window references. So you can open a window from one page and maintain a reference to that window, and that gives you access to certain properties. And the window that's opened also gets a back reference to the opener. And so when you're opening windows from one site, if you're opening untrusted resources, there is a connection there, and there are properties that can be obtained by either side, which can, again, lead to a class of issues known as cross-site leaks. Cookies are an interesting, I'm calling them exception to same origin policy because they do not follow same origin policy. They're not governed by origin. They're not strictly governed by site either. They're a little bit more unique, and we'll cover that in a future session, but it's just too much to get into now. Side channel leaks are another situation where just either because of information that you can gather from just the behavior of logic, you can infer things about resources that you probably shouldn't be able to know. And a very simple example would be timing, right? So if you assess how long it takes to load a certain resource, that might tell you information about that resource. And that's not necessarily intended to be permitted through same origin policy, but things like that are very hard to actually block and make challenging for attackers to abuse. And of course, it can lead to, again, the class of issues known as cross-site leaks. And finally, user actions, in some cases, relax same origin policy, or at least relax browser protections. Whether some of these protections fall under the category of same origin policy, I think is debatable, but there are certain things now on the web where before an attacker would not require a user interaction to do, or a gesture you might hear referred to. And now there's certain situations where to perform an action within the browser with JavaScript, you need users to interact with something as a precursor. And those interactions often can be quite simple. In many cases, clicking a button satisfies this interaction. And so that's why you'll see certain attack chains rely on some user interaction element. Of course, for these cases where same origin policy is relaxed, also in situations like UI redressing attacks, which are relatively different types of attacks, but still, I think in essence, act as workarounds to same origin policy. So let's look at all of these in depth. One of my favorites about the amount of confusion that exists out in the developer and the security world as well is cross-origin resource sharing. It's very, very common to see developers complain about cross-origin resource sharing because probably the situation is they're developing an application that has a separate front end and an API, and they're trying to get it to work, and they're getting CORS errors because they haven't implemented the correct CORS policy, and as a result, it gets frustrating, and I think it's what leads to a lot of really unrestrictive and insecure CORS policies because developers try to get CORS working, they can't, so they just implement the most permissive policy possible. Excuse me. So, what is CORS? It relaxes same origin policy, and oftentimes there's a specific focus on just for reading responses, right? It says, CORS is a mechanism for you to read cross-origin resources. And that's true. That's primarily what it's intended for. But importantly, and it's really worth keeping this in mind for attackers and for offensive security, CORS also lets us, in certain situations, send requests that we normally could not send. So it's not just about relaxing same origin policy for reading data, but it also can let us send requests that we can't normally send. So applications and servers have to explicitly opt in using the access control allow origin HTTP header. Just like same origin policy, browsers enforce CORS. Servers do not block requests. And you know this if you've worked for any amount of time in Burp. You can construct any type of request and send that to a server. All of these enforcements occur within the browser. So what's stopping you from a web application that you've made that is trying to exploit some other application are these controls in the browser. So worth keeping in mind. Oftentimes, you might start with a proof of concept in Burp, for example, and you can see, oh, I can send this request that results in this consequence. So now I just need to cause a user to send this request. And that can sometimes be the challenging part, because then you need to figure out, okay, well, how can I get a browser from a malicious site that I manage to actually send this request? It's worth also pointing out here that access control allow credentials is a mechanism that allows ambient authority type credentials, so like cookies, things that are automatically sent by the browser, to be included within requests so that you can send authorized requests on behalf of the user and get authorized responses. So the classic CORS vulnerability is where you allow credentials, the site is using cookies that can be sent cross-origin, and all you need to do is send a request to read sensitive data. You get the data back, you read it. Simple CORS vulnerability. There are probably many applications out there that are still vulnerable to that just by implementing a very permissive CORS policy. We'll talk about the specifics of that later when I do a CORS session. Just one thing to keep in mind is that access control allow credentials now will not work with a wildcard access control allow origin in modern browsers. So the wildcard policy in CORS is actually not the most permissive and dangerous, but we'll talk about that later. So CORS can permit, crucially, HTTP methods and headers not typically permitted when you're sending requests across origin. And of course, the Fetch API is the standard consumer of CORS capability. And if you want to read about CORS in good detail, you want to go to the Fetch API. I believe CORS used to have its own specification. I think it's now exclusively captured under the Fetch API, if I remember correctly. Something worth keeping in mind. So let's look at some examples. This is a very classic situation where we want to be able to read data from some endpoint. So in the client app, the application where the user has it loaded, in their browser window, they have a script that is making a cross-origin fetch. So it's making an HTTP request and it's trying to get the data and log it to the console. And in order to be able to do this, where we couldn't before, remember, because of same origin policy, we actually have to have a CORS policy that is going to permit us. So our assumption here, if we now look at the bottom, is that the origin from which we are conducting this attack is attacker.com. And so the application, when it returns the response with the data we want to read, it has to include the header access control allow origin. Very important to keep in mind. I said that this wasn't going to be a deep dive into CORS, but there are a few other things that I am going to touch on. So CORS traditionally made the distinction between simple requests and non-simple requests. Simple requests using safe listed methods, headers, and content types. These are the ones that we touched on before. These are the ones that you can make without requiring a permissive CORS policy. Same origin policy, the mechanisms of the browser allow you to make these requests by default. So simple requests qualify for what is known as no CORS mode, and therefore there's no pre-flight request that's needed, which is an initial options request that essentially checks permissions. Non-simple requests are ones that cannot be issued in no CORS mode. Simplicity is governed by request properties, while CORS mode is determined by how the response is intended to be consumed. One important note for terminology is that we refer to opaque responses as those that cannot be read by our application. And one thing that I do note as well, in the new fetch spec, they don't use the term simple. This is called out in the MDN docs, but it's still commonly used. It's still pervasive terminology. In case it's helpful, this is just a simple table of request types and CORS modes, whether pre-flights are required, and what the nature of that response is going to be. But we'll deep dive into this a little bit more when we do a CORS session. And so here's just one example of a simple request that you can send using fetch without a permissive CORS policy, compared to a request that is non-simple, where you effectively require the server permission to actually send it. And the only difference between these two that you should be able to easily see is the content type. So text versus application slash JSON. I think text slash plain in this form is permitted by default in modern browsers. I might have to double check that actually, but I'm pretty sure that qualifies as simple. Hey, good homework assignment. Test those both out against different origins and see what happens. JSON P. Okay, so JSON P is, as I mentioned, it's probably best considered a deprecated technology. Calling it a technology is also generous. It's really just a fun little hack. So the way it works is you have to have both your client application that wants to consume data, and it has to be coordinated with the server that has data. And these can be cross-origin, right? Two different applications protected by same origin policy. So how do you read data from another app when you want to do this? And keep in mind, this is a time before CORS. So CORS existing as a mechanism to relax same origin policy didn't exist when JSON P was implemented as a hack. And the way it works is you embed the content that you want to read as a script file. And as you can see in the bottom response, the content type is specified as JavaScript. So we use a script, a tag, to pull in the content cross-origin. And importantly, as a parameter, we specify a callback. And this callback is going to be a method that is executed by the script that is returned, and or the script that's being returned calls that method or function rather, and that function is one that we define. So we define a function called handle, and we're also, to our remote application, we're sending a request that has a parameter callback, and it's saying that the callback is called a handle, right? We want you, the script that is coming back that contains the data we want to read, we need you to call the handle function and send it the data. So the way that the application works that is sharing the data is it has this JSON P endpoint, and instead of just returning JSON, it wraps JSON within a function call to handle. So when this content executes, when you pull this script in, the outcome of that is that the script that we're loading in calls the handle function, and the handle function takes that data and then it logs it. So we're not reading data from this resource. This resource is giving us data by calling a function that we define. And so it's a workaround to same origin policy. And you can see that this behavior almost feels like an exception to same origin policy. It blocks us from reading scripts, but again, as I mentioned before, script content can still interact with our DOM. It can interact with our JavaScript logic. So there's really not a strict boundary if the script that we're embedding on our site has logic that in some way interacts with our page. We can observe the consequences of that. In this case, of course, it's intended, and it just sends us the data straight up to a function. But one thing I haven't seen a lot of in application security is I haven't seen a lot of abuses of the ways in which scripts can interact. Again, it's kind of rare to find JavaScript that actually has sensitive data or functionality that you might want to try and infer what that is. It is a really good practice not to include anything sensitive in JavaScript, and it's also a very good practice not to implement JSON P endpoints. We're not going to do a deep dive into JSON P as a topic in this session, but there are many ways if you find it still existing on an application, it may be abusable for one or more purposes, because this ability to craft custom functions on a remote system turns out to be a bad thing for a number of reasons, beyond just giving us a data sharing mechanism. In this example here, what was I trying to convey here? I think I might have just failed to change, get rid of this template page. So we'll skip on through that. Post message. So post message is, unlike some of the other mechanisms we've looked at, an explicit way for applications to communicate. They don't have to be necessarily cross-origin. You can have same origin communications if you need to, but it intentionally allows us to exchange data across origin. The important thing to keep in mind is that there must be some relationship between the windows that load the different web applications. There are many different ways to do this. You can use one application to open a window to another. You can have one application embed another application using an iframe. There just has to be some type of connection that allows you to send post messages, because post messages are not things like, these are not HTTP requests. These are not going out on the network. These are being managed by the browser. They happen entirely client side. There might be some side effect that sends requests based on the logic meant to handle those, but this all occurs within the windows that you have open and the pages that you have loaded within them. And there are many ways in which you'll see this implemented for many different purposes for cross-origin communication. Importantly, every message that gets sent via post message includes the event.origin property. And so this tells you the origin where that message has originated from. And this is very important for source validation, because if you have built an application that is using post messaging and you consume a message and take some sensitive action on it, you want to make sure it's coming from an application that you intended. And so one of the biggest vulnerabilities with respect to the implementation of post messaging is just failing to actually validate the origin. However, even sometimes when the origin is validated, the way in which that flow might work might still be abusable. So even with event origin validation, you still can have different ways that post messages can be abused. Actually, another example, besides being able to send malicious messages, you can also have a malicious application that intends to receive messages that are not intended for it, that contain potentially sensitive information. So, senders can deliver data, but you still can't read the DOM or the state of other applications. You're still relying on both applications coordinating, one sending messages and one designed to receive them. If an application isn't designed to handle post messages, you can send them, but nothing's going to happen. And this is just what that looks like in practice. So let's say we have a victim site and an attacker site, and you wouldn't quite see this situation in practice, because on the victim site, you can see that we do have we are taking the event in, and we're getting the origin, and we're validating its relationship explicitly to an attacker site. That is not what would occur in normal circumstances. You would say, if you were doing origin validation, you would say, hey, is the origin equal to the site that's trusted? Nevertheless, on the victim site, we see that we're adding to our window an event listener, and that's our handler for messages that are sent. And on the attacker side, we can open the victim's window and we can try to send a message to it. And that message includes two things, of course, our message content, and then the origin that we're actually targeting with that post message. Another example of kind of an exception to same origin policy, metadata reads. So images are another great example where we can't read images pixel by pixel when we load them in, when we embed them onto our site, but there are properties nevertheless that are exposed to us, like the width, the height. There can very well be situations where we might be able to read the properties of something that's loaded in, and that lets us infer something. And that inference, in combination with how whatever application, with how that application works that we're loading that image from, again, might let us deduce sensitive information, or even something as simple as, like, is this a user that is authenticated to this application? And that can be valuable, right? Determining that someone who's browsed to your application that is malicious has an authenticated session with another application that you might want to target. That could be useful information for for one or more resource or for one or more reasons. And I guess I have another little extra slide here. And there are many cases of being able to read properties from things that you embed that might lead to leaks depending on the target application. One of these situations that occurs, I wouldn't call this metadata leaking. I classify this instead as information you get from a cross-window reference. But if you have a reference to another window, and remember, you can open a window cross-origin, and you can retain a reference to that window, and so you can interact with certain properties. And one of the classic properties that is such a strange thing to exist that you can get from windows that you open cross-origin are the number of frames that are loaded in that window. And this is a capability that's not sure why it exists by default, why it's permitted. But nevertheless, it does exist, and it has been used to build exploits that leak information from certain applications. There's a really classic example at the in the early era of cross-site leaks as a class of vulnerability, and it involved using Facebook. The way it worked was Facebook had a graph API search, if I remember correctly, and the way that search worked is an attacker could construct cross-origin requests using that search API, and they could make those searches increasingly very narrow to try and determine very specific things. Well, how do they determine specific things? Well, all of the search results that were returned by the graph API were embedded in iframes. And so if you can count the number of frames that are embedded in a remote resource when that response comes from an authenticated user, well, you can infer the results of the searches that you're making. So you can make a very specific search, like, get data from this, possible, I guess, friend of this user on Facebook. And if you get a hit, well, you know that person is a friend. Excuse me. Cookies are another great example of something that are not governed by same origin policy, and so there's no boundary between origins. This is actually a poor example because I don't state what origin we're sending it from, but cookies can be shared between subdomains is the point that I'm trying to make here. So there are situations where cookies are sent even when you're making a request from a different origin. The origins might be different, the sites might be the same, and it's important also to keep in mind that there are a large number of different types of requests that you can make. In this case, I'm making a request for an image. In some cases, that image request, which seems benign and it seems like it maybe shouldn't include cookies, but the browser will include cookies by default in many cases. I think more than ever now, there are an additional number of rule sets that determine whether cookies are sent in this case, like for an image request. And I'm not just talking about the same site attribute, if you're familiar with that, but also browser to browser differences in behavior, and also how users are configuring their browsers. But we'll dive into that when we talk about cookies. Finally, and I mentioned this before with respect to timing, side channels also can exist that allow you to infer information that you probably shouldn't be able to do. And one way to do that would be just looking at how long a resource takes to load. That can let you determine information about it. There are also ways in which you can determine whether a user's browser has cached a certain resource, which tells you if they've visited it before, which can tell you information about that user, the behavior, the applications that they interact with. So this is a very, very complex set of issues belonging into the category of cross-site leaks. And as far as I can tell, it's still kind of evolving, right? It's an evolving area. In some cases, you might require a user interaction in order for certain behavior to actually occur. And when I mentioned different browser restrictions and behaviors around frame counting, I think that in some cases, interaction might be required for that issue now, where a user would have to explicitly click a button or perform some other gesture in order to do frame counting attacks. I can't remember exactly. As I mentioned, these state of protections kind of have changed a lot over the years. But if you're very curious about the current state of things and what attacks work and what don't, there are some resources that are up to date that I will share alongside this video. But it's also just always worth experimenting with, and consider setting up a test bed to try different cross-origin interactions, and also consider trying different browsers as well, because different browsers do in some cases behave a little bit differently. So what are the considerations for security testing that we need to keep in mind around same origin policy? So cross-app security, the term I opened this presentation with, really depends on the security mechanisms in use and the application-specific functionality in conjunction with that. A lot of vulnerabilities that do exist in practice are not just because, oh, this application has implemented, like a permissive CORS policy. It often requires a combination of the configuration of security mechanisms like CORS and other mechanisms, the quirks that exist within same origin policy, as well as the specific functionality and behavior of that application that make it abusable with those mechanisms. As I've pointed out, not all security boundaries are enforced by the same origin policy, and it's not even there isn't even necessarily a strict and clear set of same origin policy rules that apply universally to all browsers and situations. At best, it's, I think, best thinking of same origin policy as a model that constantly has an evolving rule set, and that rule set is probably going to continue to change and evolve as well. Same-site attacks can be more capable than cross-site attacks, even when applications are cross-origin. That's something to keep in mind. Cookies play a lot into that when we talk about cookies. Same origin policy allowed behaviors like embedding, navigation, messaging, metadata definitely can create meaningful attack surfaces. And finally, security testing must evaluate the interaction between applications, not just applications in isolation. That's the main thing that I'm trying to drive here. A lot of really interesting vulnerabilities arise from these deficiencies in these intended boundaries between applications. And I think a lot of traditional application security is really focused on, just targeting one application, trying to exploit like server level vulnerabilities, injection vulnerabilities, things of that nature. But there's a lot of interesting surface area when looking at, okay, what can we do from other applications that could exist? And one of the really challenging things to do is also looking at a set of applications that have some existing level of trust relationship. Maybe it's a suite of applications. They've got post messaging between them. They've got CORS policies to allow for data reading between them. And it's always a fascinating journey to look at each of those applications in combination, determine what the mechanisms are that allow interaction across origins, and also identifying all of the specific vulnerabilities that might exist in each of those, and determining how can I put all of this together to come up with the most impactful exploit chain or vector to exploit users or the application. So that's it for this session, but I thought it would be worth calling out what we haven't really covered in depth, just so you know the scope of what we are going to cover and what we haven't covered. And this probably isn't even it for everything that I would like to cover on this topic, but we are going to look at HTTP cookies in depth, web storage and caching, cross-origin resource sharing, touched on it a lot, but we haven't covered everything, post messaging and iframes, site isolation, which is a relatively new concept, which does have major implications for security testing, modern cross-site request forgery. I say modern because it feels like a lot of people see it as a less viable attack vector with the introduction of same-site cookies, which are now to some degree enforced by default by browsers, but there is still a wide landscape of viable cross-site request forgery vulnerabilities, but oftentimes it requires thinking outside of the box of traditional CSRF attacks and using many more mechanisms that are at your disposal. Cross-site leaks, of course, or XS leaks, as you might see online. I'm going to cover UI redress attacks, and finally, content security policy and trusted types, more mitigations for cross-site scripting, but I think also worth covering. And maybe there are even more lessons to come that I haven't conceived of yet. But as of now, this is the current plan. So hope to see you in those forthcoming sessions.